So I'm just going to assume that you're in a good rhythm by now, that you have watched this video, that you have watched this be done, that you have watched this happen, that you have taken good notes on this, that you have done this question, and that you have grappled a little bit with this. So what I'll do is I'm going to work through my solution. But for the solution for this one and for the question on the other side with the Norman window, I'm going to tease a little bit at the beginning, and then I'm going to pause, and that's going to give you an opportunity to hit the pause button and go back through once you see, oh, that's how it sets up. And I'd encourage you to do that. You don't lose anything by hitting the pause button. I'll still be here. But if you just watch it straight through and you don't take time to say, oh, well, if I had known that, I could have gone somewhere. If you don't work that aspect out, it's going to be a real doozy when one of these hits you for real. So let's talk about this particular question. Here's the 0.30. This is the 0.30. You can draw lots of line segments between 3,0 and points on this curve, but we know that one of those segments is shorter than the others. This is the line segment connecting 3,0 to some generic point here. It's got an x value of x, it's got a y value of y, and we know how to find the distance between those points because we passed high school geometry. And so the distance between those points is the square root of, and then we do difference of the x's, difference of the y's, square them, add them, take a square root. This is the distance formula. For those who care and can do algebra, this is the distance between those 2 points. So what do we know? We know that if we were to graph this function, it bottoms out somewhere. We are interested in where it bottoms out. Where it bottoms out, its derivative is 0. So we are interested in finding d prime. What's d prime? Well, that's the derivative of this thing, and this is blah-bitty blah to the 1/2. So how do you take the derivative of blah-bitty blah to the 1/2? 1/2 blah-bitty blah to the negative 1/2 times, I hope you know where that came from. Now, pause. Can you finish it? Well, if you can finish it, you're trying to set d prime equal to 0. This part can never be 0. That's never 0. This is the denominator of some fraction with a numerator of 1. This cannot be 0. So if any part of this is going to be 0, this part is going to be 0. And maybe you're really good at algebra. Maybe you graph the thing. X equals 1 is the only place where that cubic is 0. We confirm, here's a d prime chart. We can confirm, we can confirm that d prime is negative on the left side of 1 and positive on the right side of 1, which does guarantee that x equals 1 is the minimum. And so then we answer the question, what is the minimum distance between the graph and the point? Well, that would be the length of this segment, where this is the point 1, 1. And so that's the square root of 5. The minimum distance is the square root of 5. And that's if this is the point 1, 1. Let's take a look. What do we know? We know that the perimeter is 100 meters. Well, what's 100 meters? This, 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 add up to 100. This is some radius of a semicircle, which means that this is twice that. Circumference of a circle is 2 pi r. We only need half of that. And then you have some length here, and it's the same length over there. So what's 100? Well, the 2r across the bottom and the pi r across the top, and two lengths have to add up to 100. And so algebra is going to tell us that one of those lengths is 50 minus r minus pi over 2r. So what are we trying to do? We're trying to let the maximum amount of sunlight in. So what are we trying to make as big as possible? Trying to make area as big as possible. So pause. Now that you've seen this much, pause. Can you write the area of the window completely in terms of r? If so, see how far you can get. And then click play, and we'll see if we're right. What's the area? Well, it's the area of this rectangle, base times height, and the area of a semicircle. So still no derivatives yet, just algebra. Just algebra. And this is a plus half pi, so there. So now what? What do we know? We know that if we graph this, it tops out somewhere. I want to know where it tops out. Where it tops out, its derivative is 0. Well, what's its derivative? 100 minus 4r minus pi r. We want that to equal 0. And so r turns out to be 100 over 4 plus pi. And you can confirm that the area is increasing before that value and decreasing after that value. And so what is the answer to the question? How wide should the base of the window be? The base of the window should be 2r. That's 200 over 4 plus pi. That's 28.005 meters wide. All of these problems run the same way. There is some function you're trying to maximize. That function usually has two variables. There's usually some other piece in place that helps us deal with that second variable. Then we take a derivative, set it equal to 0, and solve. We will practice more of the same at the start of next week because we're going to need to. So take the weekend, practice some questions, and then come back ready for Monday.